This conference will now be recorded.
Hello, a very good morning to all of you who have joined for this session. Welcome to our day 2 on webinar on integrative design approach. Today we have our master trainer Mr. Kumar Biplavji. It's a privilege for us to have Mr. Kumar Biplav as our master trainer today. He has more than 10 years of experience in energy audits, retro commissioning, project management, etc. Currently, he is working as the Vice President of Engineering at Livolt LLC, and he is also the founder and principal consultant of Kumar and Associates. He is a mechanical engineer and a postgraduate in energy and environment from IIT Delhi. I welcome Mr. Kumar Biplav to the webinar. Over to you, sir.
Thank you so much. Right. Can you see my screen?
Yes, sir.
Okay, great. Okay. So what we'll do right now is we'll very quickly, because all of you know Equest, what we'll do is we'll very quickly see the major inputs that go into Equest software, and then what we'll do is we'll look at the reports and we'll see what information can we find from the output report. So that's the agenda for the first half, and then in the second half I think we'll talk about more about errors that we get in Equest, and if anybody who has had any problems in Equest, I think we can try and rectify that. Take a look at that. Yeah, so let's get started, and I'll create a new building. So I have the Kerala weather file. That's Thiruvananthapuram. Okay, and yeah, so we remove all these holidays. Just a quick recap of what we were doing earlier. Okay, and what I'm going to do is I'm going to focus more on the detailed, how you can switch from an air side to a water side and other things. I'll leave the default as this. We'll try to look at more at how we can do things at detailed level. Okay, so just excuse me for a minute here. Yeah, sorry about that. Okay, so the first major thing after you have given the location, you can always check the weather file over here. Just make sure that this weather file, even before you begin your simulation, even before you click on simulation, I think the best thing you should do is look at the weather file. Just make sure that you have the weather file correct. Now after that, let's look at the constructions. So this is one of the major things. I would always recommend that you have a single type of construction, but sometimes people prefer different types of construction. The architects can be, they can try and fit in different types of construction, but it's always good to prefer a single type of construction. So here on the left side, you have the wall construction, the roof construction, and ceiling construction. So ideally, I would say that although, as you can see over here, the ceiling has been provided, in big buildings, I really feel that you should not go for a ceiling zone. One of the primary reason for that is because you're comparing two cases, which is base case and the proposed case. So this is going to increase your complexity, because ultimately what is going to happen is that you will have to deal with a number of zones. As you can see, for each, another plenum zone has been created. Okay, so a good question from Mr. Basil, from where we can download the weather file. Okay, I'm going to show that right now. One second. So all you have to do is search ISHRAE weather data. Okay, now here you will see the first option will be white box technologies. Please use Google if you can. I do not know how Bing or any other search engine will show up the results. Google shows up this one. Does anybody still use Bing or any other they prefer, or they prefer online? I mean Google. Let's hope you all prefer Google. All right. So you can go inside this, click on this. Oops, not sure why it's not opening. Okay, I think the server might be down. Some maybe. Oh no, here it is. Yeah, there you go. Okay, so here you can actually select. There are 62 stations, as you can see, for which you can download the weather file. And let's say you want to download for Thiruvananthapuram or something like that. All right, so you can just choose whichever you want from here. Let's say Thiruvananthapuram, click on that, and okay.
Kumar sir, from historical weather file.
Why would you need historical weather file? Like, this is the weather file which you need to use in the simulation. So once that, you go to cart and try selecting one at a time, because if you select one at a time, it is free. If you select all the 62, it will be it will then ask you to pay. Okay, so as you can see, the price is $0. Check out. Who said it is EPW file? You do get bin M or bin M2 files. So let's look at. In fact, When you download, let's go to, okay, 1 minute. Let me just do this. Okay, so once you download, you get this download link. Save file. Okay, so this is the file that has been downloaded. I'll extract. And if you look inside, you have this binm file. Okay, so that is the file that you can use for simulations. You do get EPW file also, but you also get the binm file. Let's look at, in fact, I also want to look at, there's another weather source, ladybug. Okay, so this is another tool from which you can actually get all sorts of data. Let's look at India. What back Kerala? Okay, that's good. We have another one for Kochi. Okay, let's see what kind of weather data we have here. Okay, so we have EPW file. That's good. Now what we'll see now, if anybody who doesn't know conversion of an EPW file to the Equest weather file, this is for them. Anybody, like, does anyone who doesn't know how to convert? Would you like me? You can type in the chat box. Even if one person who doesn't know, you can tell me. Otherwise, I'm going to skip this step. Okay, great. So let's take this EPW file for Kochi. All right. Now, how are we going to convert it into an Equest weather file? Oops. Right. So let's go to DOE2. In fact, and this one. This is the home page. Here you will see weather data and utilities page. Click on that. And then here you will find EQ with prop. So this means Equest with processor. So this converts Equest EPW files into Equest and DOA2 bin files. So let's go ahead and download that. Now please read the instructions very carefully, whatever is given over here. So download the program, archive into your Equest/weather subdirectory. Okay. So here I'm going to go and unzip this. So undo is rename this. Okay, I'll rename this. So all I did was cut this and I'm going to paste it into documents, data, and within weather. Okay, here I'll paste this. I'll rename this. Next, I go inside processor, and you will have this configuration settings file. So this is what it sees. If you look at over here, it says delete the EQ with prop.ini file. It's always good to delete this EQ with prop.ini. If you do not see the last 3 digits or the extensions, what you can do is go to properties. Sorry, I have kind of forgotten where you can actually we go no. Oops. Give me a second here. Okay, yeah. I think this is here. Yeah. So if you are running Windows 10, go to View, and then under Options, click on Change Folder and Search Options. Go to View, and here you will see something called as Hide Extensions for known file types. So uncheck that. So what will happen is you will start seeing these extensions .exe, .ini. So I'm going to show that. If I check this box, hide extension, so what will happen is, as you can see, the extensions will vanish. The other way is you can just see this is the type is configuration settings. So you have to delete that file. Okay. So configuration settings file, delete that, and that's it. Here. Okay. Okay. Yeah. All right. So next, all you have to do is double click on this, select your file from wherever it is. It was in downloads. The Kochi file. I'll select the EPW file and I'll click on convert. And that's it. Here you'll see the bin file. Oops, that's the bin file. And take that. Yeah, please everyone mute so that the voices can be clear from my side. Okay, thank you. Yeah. So that's your weather file. Yeah. And you can put it in here in this folder. So that's a Kochi file, and then now you can use this file if you want. Let me see if it can be sent from here. No, can share files in the chat. All right. So that's that. So that's how you convert the files. Okay. All right, perfect. Just give me 1 minute. Hang on. Yeah. Now another thing, maybe you might know this or you might not know this. How do we change the background of this to a white so that when you take a photograph for your reports, just like this, the background should come white, right? So that's a good thing that you must keep in mind. Is in the detailed mode, double click on the project name over here, double left click, go to 3D view and switch the background color to white and click on close. So what will happen is you'll get this nice image which you can use in your reports. So one good question is it compulsory to download same location of the city while doing works in Kerala? So as you can see, as of now, we just have weather file for only 2 cities, either Kochi or Thiruvananthapuram. So you will have to use either one of these. Maybe put a line over here. Thiruvananthapuram will be more suited towards south of Kerala, and Kochi will be probably more suited towards north. Of course, you have Malappuram and Kozhikode. Kannur maybe. So here, let's see. Let's see if we have EPW file. Oops, the URL was not found. So Kozhikode you don't have. Yeah, Calicut you do have. So you just have these 3 weather files with which you can work out. Okay, maybe north side, maybe where there is a mountainous region, I'm not very sure. Maybe you can take Mangaluru, but Mangaluru climate may not be that suited. But if we go back to the question, is it necessary to use the same location of the city while doing works in Kerala? No, it is not. You just have to look the nearest city for which you can use. For example, if a place is somewhere over here, you could use either Kochi's weather file or maybe even Coimbatore. So that's up to your expert judgment. There's Kodaikanal also, okay, which is a hill station. So yeah, okay. So for example, for Munnar, if there's something in Munnar, maybe you could use Kodaikanal. Could be it will be almost similar climate zone. Excuse me, 1 minute. I'm going to answer that question, Ashokji, in 1 minute. Just give me 1 second. Yeah. Okay. Coimbatore being east side of Western Ghats may be less suitable. Coimbatore, let's see, where is Coimbatore? Not sure where is Coimbatore. Okay, this one. All right. Okay, yeah, that's an expert judgment that you can take. So there's no hard and fast rule. Ideally, what we try to see is that the climate zone should be almost similar to that of the location that you are selecting. For example, if I say Munnar, I would prefer Kodaikanal rather than Kochi. Okay, right. So that's that. And another good question is from Mr. Ashok. How to make the SLD origin when I pick it from DWG file? So the best option is if you go to if you prepare any SLD. Okay, let's say we have a new, and as you can see, this is the origin. And let's say you have a plot, sorry, a single line diagram, something like this. Let's say this is your single line diagram. So it is always suggested that before you save your SLD or before you import the SLD into your Equest, always move the corner point, whichever you want it to be, at 0, 0 to 0, 0, and save this. Let's say call this as Untitled 0, and let's say I want to import this. Change the mode, yeah, step. Okay. Now, when you import it, you'll see if you go to a blank slate, import CAD file, you see it gives me 0 and 0. Straight away, it gives me 0 and 0. So when you apply that, what will happen is it will come to the point 0, 0. Now let's see if, in fact, what happens. Take a common point from there. There may be stairs. The stairs will always have a very common point. For example, let's say this is the stairs. Okay. Now floor 2 might be, this is floor 1. Floor 2 might be, let's say, bigger than this. So pick up the stairs as the common 0, 0 point. So if I say, if I pick this one, oops, I'll move this to common 0, and this to, try to pick up a common 0 point if you can. Now if you can't, let's see a situation where you cannot do that. Okay, let's see the alternate also. I'm going to delete this, and somewhere over here. And I'll save this. I'll re-import again. Okay, so it automatically, as you can see, it automatically takes the x and y coordinate of the bottom most left corner, whichever it may be, wherever it may be. You might, so let's say if you have a building like this, L-shaped building like this, let's say if you have a L-shaped building like this, it will pick up this point. You can see my cursor, this point will be automatically picked up. So in this case, let's see, 3059.7.127. So if I click on apply, automatically comes at this place. Okay, so this is Untitled DXF2. Let's see if we can detach. Okay. Yeah. So I'm going to save this once again. Now you'll see this point will be the one which will come. See, the Y has shifted. Now if you click on apply, as you can see, it is the common intersection which is automatically taken by default in X and Y coordinate. Yeah, you can always edit the coordinates in dialog box. That's perfectly fine. But always start. It's always preferable have a very good common point which is running throughout the building. It will mostly be either stairs or lift or staircase. So either one of these should be moved to 0, 0, and then everything else like different floors will always line up in your 3D view. You won't have to worry about it. So let's, let's do this one. Okay, I'm going to create a new shell and I'll put it immediately above. So always check this exact site coordinates. Sometimes because of this, the movements can be there. So here, custom. Let me change a little bit more over here. Let me save this. So now our common point was this, and in fact somewhere over here. Let's see how this stacks up. Okay, so previous whichever x and y coordinate, because you have copied it, it will come automatically. So what you see over here, wasn't it saved? It was. Okay, in fact it has come over here. Background, if I click on none, let's see, in fact, okay, it is showing this background. Let's try again. Blank slate, DXF, apply. It still comes in at this as you can see. Okay, so we will have to now, change the coordinates later on. Let's look at, oops. The geometry is the most critical aspect where most of you will face issues. So it's always better to think a little bit ahead. Let's see. Now, if I return to Navigator and if I click on Finish, if I go to 3D geometry, as you can see, it's not lining up correctly. There is a difference over here. Now, let's say you have already entered detailed mode, and because you have made a lot of changes, and now if you go back to wizard mode, you will lose all the changes. How is it that we can rectify this situation such that this comes at the correct location? So for that, what we'll do is we'll just look at the X and Y coordinates over here, okay, of this EL ground floor and north floor. So you can actually view it. So if I change this to 0, you see what happens? It moves to the right. Sorry, it moved to the left. So there is no undo button. So do remember the coordinate which you had earlier. Okay, so now what I'm going to do is I'm going to try and find out the extreme end coordinate of this. Okay, so that it lines up perfectly. You don't need a perfect match, but because there is a roof over this, it will have an impact, but ideally it will not. If it is one upon another, speaking from a very technical point of view, the moment I delete these roof, okay, it really does not matter, technically speaking, because since the roof is gone, there is no longer a heat gain which is happening inside this space or the plenum. Okay, I delete this. Oh no, sorry, this roof should have been there because it covers this covers. So I'll keep this roof. Let's say you accidentally deleted. You can always create another. So just copy the roof, and that's it. Oh, sorry, I selected the wrong one. You can always check where it is. Okay, so it has been created on the, as you can see, the red. Do you see the red one? That is where the roof has been created. So I'll probably delete this because we went to the wrong floor. We want to create in the plenum zone for this one. So create it here. As a wall, I'll copy a roof, and that's it. So you can see the roof is. Still, you will encounter such issues where you accidentally delete something. Don't try and go back, because there's no undo button in this case. Don't start from scratch. Okay, and now for a visual look, of course, you have to move this. So what I'll do is I'll try to find out the coordinate for this one. So I'll go to 2D geometry. Before that, I'll select any one of these so that this space is selected. Go to the 2D geometry and click on this shape view mode. So when I click on this shape view mode, I can actually find out the approximate coordinate. I don't need to be exact, I just need the approximate coordinate. So if I have to place it over here, my X and Y coordinate should be, as you can see, 48.1 and 0. So if I shift to 48.1, okay, this should ideally line up. So I'll select this and I'll change this to, now you can see the change when I change it to 48.1. There you have perfect alignment. Okay, similarly for the top one, top floor, 48.1. There you go. There you have perfect alignment, and of course I need the roof. In fact, it is half a roof, but doesn't matter. So you have the ceiling in the core space. We want it in the, sorry, in the perimeter space. So let's look at which is the plenum zone. And yeah, if anytime you click and this vanishes, just reset camera, switch to internal nodes, and then back to building shell, go to 3D geometry, you'll be back again. Okay, let's look at this. This is the core plenum. Yeah, this is where I want the roof. Copy any other roof, and there you go. Okay, so these are the techniques in which you can actually move around and play around with your geometry. So yeah, good. Please keep asking queries in between. You know, that's really good, so that these things can be clarified. Okay. Now let's look at the other inputs. So I was talking, your wall, roof are the ones which are most critical. Underfloor constructions, doesn't matter what you have construction. What this means is that it is adjacent to ground. So you can actually, if you have a simple floor construction, which is an I floor construction, which is just concrete and linoleum tile, you can, what you can do is right click on this, click on delete, and ask you to reassign. You can straight away reassign to I floor construction. In the climate zone of Kerala, or in fact anything except cold climate, it's all right if we do not model the ground resistance. It's perfectly fine. So go ahead and reassign it to a simple concrete floor construction. Just be careful which construction you are assigning. So what this does is it clears your all, you know, it makes it very simple for you to look at everything. And also it will be easier for the checkers when you submit the model. You can change that. Okay, so good questions that everyone has put up. We'll take up one by one. Okay. Now we'll always, if you remember, there's a saying, we say the word kiss. So what it means in engineering terminology is keep it simple, stupid. So that's what it's all about. Keep it simple, as simple as you can. So when it comes to odd shaped buildings, let's say where you have tilted walls like this. In that case, what should you do? That's the question. But it's very unlikely unless some fancy building is coming up. It's very unlikely that you will encounter those types of buildings. But you can always tilt these walls. Now let's say I have this wall. I can actually tilt this. You see this tilt 90 degree? I can actually change it to 60 degree. You see the change? It has tilted. So first and foremost, create that entire vertical building. So in that case, you will have to apply a bit of geometry. So where your point stands, if you create a vertical wall, and then how will you tilt it? Okay, so that everything fits into one place. Okay, ultimately, what matters is that the area, the exposed area for wall glass should remain same, and the direction. So that's with respect to the oddly shaped buildings in which the walls are tilted. Okay, now I'll change this back to 90. Let's take a case where you have a semicircle, let's say. Oops. Oh, it's by 3 point. Sorry, give me a second here. R by 3 points. Where's this? This snap. There you go. So let's say if you have something like this, a semicircular or a circular type of building. Yeah. What will I do is the question. How will I determine this? So best is create, so I'm not getting this, maybe, oops. So create something like this. Break it down. There you go. And I'll delete this. So this is how I will create my geometry. So it's not, you can always further reduce the number of lines, but that's of no use, because what you're going to do is you're going to make the model slow, because there'll be a lot of walls. Right? Yeah. I hope you're able to get a bit of idea. Trapezoid, for example, a trapezium. So trapezium is always,
Sir, sir, I think you are on mute.
Oh yeah, I'm so sorry. So sorry. I think everything.
Can you please repeat, sir?
Yeah, absolutely. I'm going to repeat everything. I'm so sorry. Okay. I think from where we stopped. Okay. So odd shaped buildings. All right. So first of all, I'll repeat what I had said regarding tilting the wall. So if you have a trapezoid, something like this, you can change the geometry by taking this tilt angle. Yeah, that was the number one that I showed. Okay. Number two that I was showing was, let's say if you have an arc like this, so you break it down. You break down that entire arc into number of lines. Now please don't increase the number of lines. Okay. You have to keep it very simple. Okay. The funda is keep it simple. So I broke it down into 4 sections. The entire arc I broke it down into 4 sections. Now you could say, no, this does not look the exact similar geometry, but that's not our concern. Our concern is energy. I'm not the architect. You're not the architect. Your concern is energy. You know, this much area is going to cause negligible losses. I mean, energy or difference in energy. So you have to take a balance, and you just can't, you know, if you say, no, I want to do it, I want to break it into several pieces, do it, go ahead, try it. But then what you'll be ending up with is that you will be slowing up Equest. Okay, so that is why it's always important to keep it simple. What was the other thing that I was showing? I think where okay, the dialog coordinates, I think that I have shown. Is there any other thing which I had showed and I missed? I'll take up this the parapet wall. From there I'll be taking up. Okay, is there any other thing that I missed? Maybe because I was on mute. I'm sorry, I was on mute. I could not you know, was audible till trapezoid shape. Okay. All right. Okay, so this is the trapezoid shape. Okay, so keep it simple. You know, this should be a simple geometry which you can straight away import and do it. Now this is the plan view. Please note that I'm talking about that in the plan view. Okay, so Mr. Amal, there's one question that you had asked. In this case, what will be exposure for second floor? Is it over conditioned space or exposed to ambient conditions? The second floor, in this case, so as you can see, I have deleted the roof in the plenum zone on this in this side. Why did I delete it? Because what will happen is, what Equest does is, if it finds a roof, it will say that that roof is exposed to exterior, even if you have a floor above. It does not consider shading. So if there is a roof, what it will do is it will straight away consider that it is exposed to outer surface, outer ambience. So now the question comes, in fact, this is the next linked question, which is asked by Mr. Subramaniam, how to create parapet wall and when you have projections, So if you really want to have shades, you should model it as a shade and not as a wall or a roof or even a building. So for example, if I just create a building on the side of it, the shadow, it is not going, this model is not, this floor is not going to consider the shadow. It will always consider as a standalone. So same thing goes. So it will not calculate the shadow projection, in the afternoon. What will happen, because you see this wall, this is the south, this is the west. So in the early morning, what will happen is this entire block is shading this portion on the left side. The right block is shading the left block, correct, in the early morning. So it's not going to consider that. It's straight away going to consider whatever the projection it is falling on the surface. It is going to take it as a standalone surface. So that's how Equest works. So you have to really know ins and outs of Equest, and then you can model however you want. So if I really want to, for example, you can have solar panels on rooftop, for example, parapet wall, or any kind of shading, right? Yeah, absolutely. Okay, we'll come to the double heighted in a moment. Double heighted in a moment. So let's take up shading. How do we create shades? So on the left side, if you see over here, you have fixed shades and building shades. The difference between fixed shades and building shades is that fixed shades will just stay fixed, irrespective of, if you rotate the building. So if you might be knowing that in the base case, you have to rotate the buildings 4 times. So if you create fixed shades, the shades will not rotate. The shades will stay where they are. They will not rotate with the building. So always go for creating building shades. Now, in this case, again, the coordinates are important. Which coordinates I want to make? So let's say, let's start with parapet wall. The parapet wall, the first, I can say 48.1 is my starting point, 48.10, and my length will be equivalent to, or I would say width will be equivalent to this width, so 48.2, 48.1 and 48.2. So let's go ahead and create a building shade. And of course, the height where it is located, oops, sorry, height is 3. Okay, so 48.1 plus 12 is 60.1. So at a height of 60.1. So I'll create building shade, use rectangle, height I'll say, let's say 5 feet parapet wall, width we had 48.2, I think, if I remember. Yep. Now you have this XYZ coordinate. My X coordinate is 48.1, Y coordinate is 60.1. Okay, oops, where did it go? 63.1. Yeah, 63.1. Oops, no. So, oh, the Y coordinate. The Y coordinate is, sorry, is 0. The Y coordinate, sorry, I was talking about the Z coordinate. Z coordinate 48.60.1. Okay. Now you can see this is somewhere in air. Uh, 48.1 is, oops, Z is 36. Sorry, 36 plus 12 is 48. So I have to give it 48. 48 plus 3 will be 51. Let's go for 48. Sorry. Okay, so you have here, as you can see, and if I just make this tilt as 180 degree, oh, sorry, 90, the azimuth as 180, there you go. Okay, can you see this? It's exactly, so this is how you create a parapet wall if you want to. And you can always create on all four sides. If you want to create solar PV, you can create solar PV similar to that, but you need to find out the exact X, Y, Z location. That's the critical thing. And you can always, you know, do all sorts of tilting and azimuth and tilt, you can always change. Okay. So does that make sense? Specific to shading? Does have anyone have doubt regarding shading? Yeah. Is there any point in modeling parapets and solar PV? Yes, there is, because let's look at the KECBC. KSECBC, sorry. Now let's go to the table 11. Let's look at, so the left one is the proposed building, the right one is the standard design. Okay. Now read this line. I'm not sure if this can be highlighted. Oh, let's see the drawing tools highlighter. Okay. No shading projections are to be modeled. Yep. Can you read this line? No shading projections are to be modeled in the base case. So yes, I can obviously, if in base case I do not model any projections, I can model, and here as you can see, in the proposed case, permanent shading devices such as fins, overhangs, and light shelves shall be modeled. So this includes even your solar PV, your parapet wall. All these are permanent shading devices, kind of they shade. So yes, they are going to reduce the load on your roof. Okay, because your maximum impact comes, the solar radiation, the maximum impact comes on the roof. So if you can reduce the amount of radiation on the roof, you can always reduce the proposed case energy consumption vis-a-vis your baseline case. Right. So let's take up a few questions before. So if Mr. Basil asked if self-shading of building itself is not taking into consideration, then heat load will always be higher. Yes, it will be higher, but again, you are comparing two cases. One is the baseline and the proposed. If it is the same in the baseline, it's the same in proposed also. So you're basically comparing. So it's apple to apple comparison. Although the loads will be higher, but you are comparing apple to apple. Okay, it's not apple and oranges. So if in the base case this shading is not being taken into consideration, then in the proposed case also this shading is not being taken into consideration. That is self-shading. I'm talking about self-shading only. But for projections, you are free to model. You can always do it. Yes, another thing, in fact, could be, we delete this or let it be there. So you have those, in fact, in atriums and mostly mall atriums, what you will have is translucent sheets on the roof. Okay, so this roof would actually not be opaque, but would be a translucent kind of a plastic sheet. So how are you going to model that? Now you have to understand that if you create a wall like this or a roof like this, it will always stay opaque. Okay, and then of course you can put in some amount of glass. That's option number one with visibility. So I can probably put some glasses over here. I can create child component, child window, create from scratch. I can take one from library. Highlights, let's see. Yeah, translucent dome. Yeah, and 15 feet, 30 feet. Okay, let me in fact see what are the height and width. Okay, how do you find out the height and width of this? So if you look at this, it says it is using EL2 space polygon 5, right? Or you can just straight away look at here. Okay, the height and width is not given. So what I'm going to do is I'm going to use this EL2 space polygon 5 to find out the dimensions. So I'll on the left side EL2 space polygon 5. As you can see, I have the vertices. So 18.2 and 84.45. Okay. Width is 18.2. Okay, as you can see. And the other one was 84.45, I think. There you go. Okay, so as you can see, it is double acrylic translucent glass. Now you can change the properties from here. So as you can see, shading coefficient is 0.66, conductance, visible transmittance. You can change all of these if you want. So this is specifically to those plastic sheets which are on top of shopping malls, especially atriums. So you can use this kind of technique to actually model the atriums, right? So yeah, another question is whether rooftop will be sloping in Equest. Yes, you can make them sloping. For example, this roof, just change the tilt. Say make it 10 degree, or let's say 30 degree. Okay, so here you can see the tilt. You can change the tilt. That's perfectly fine. So all of these can be done in detailed mode. Now, ideally, if it is only 5-degree tilt, especially with factories and industries, they have about 5-degree tilt, don't model it. But if it is somewhere like 20-degree tilt, yes, do go for modeling. Right? So I'll tilt this back to 0. Okay. So I think one pending question still remains is the double heighted rooms and corridors. Is there anything else that I'm missing? Probably if somebody might have asked a question earlier and I missed talking about it, you can just type it again. Right. So let's say I want to make this, let's say this is a banquet hall, which is double heighted. Okay, what will I do? What I'll do is plain and simple, I'll increase the floor to ceiling height in this case. Before that, I will take all of these up. So for example, core plenum, I have the Z value over here. Instead of 9, let's say I move it another 10 feet. I'll take it 19. That should do it, I hope. Make it 19. Yeah, everything is moving. Oh, sorry. I'm doing it on the wrong one. I'll just rechange that. This is 9. This is also 9. Oops, sorry. Yeah. So the top floor, I'll change the top floor azimuth to, let's say I'll move it 10 feet up, make it 46. Yeah. And the parapet also, I have to move it another 10 feet. So this will be 58. Okay. Then I'll move this plenum, right? So instead of 9, I'll take this 10 feet up. Let it go. Hope so. Core plenum. Okay. This is 19. This is also, take it up 19. All the plenums I'm moving. All right. Oh, sorry. Again, I did a mistake. So you have to be a bit careful. I was doing it on the top floor. I should have done it on the middle floor. So I'll undo that. Okay. So this is back to square one, wherein all I've done right now is I've moved this 10 feet up. Earlier it was 36. I moved it to 46. So I have my top floor, which has moved up. Next, what I'm going to do is this one. On the middle floor, I'm going to move this up 10 feet. Okay, that's core. This is 19. And this is 19. See, everything is moving up. Make it 19. And finally, this one. Make this 19. Yeah, as you can see, Now this is the void. All I have to do now is increase the height of these spaces. So floor to ceiling height, I'll make it 19 feet. So there you have my double heighted space. Okay, so everything can be done in detailed mode. There you go. Make this 19. There you go. So you can see the difference, right? So you have this, oops, sorry, double heighted space. You can just see the inside in the wireframe mode. Okay, so this is all double heighted, and the core space, this is also 90. Ceiling height, this is 19 here, and the north one, this is also 19. So there you go. There's your double heighted space. Right. Two more questions is intermediate floor construction and how to model basement. Okay, modeling basement, all you have to do is, you can just start from, take it 0 itself. In India, it does not matter too much, and apply those constructions. So basement will be your level 0, but just in case, if you are really interested in modeling a basement, you have to do it in wizard mode. So let me start a new project. Continue to navigator. So here you can see you have the option. This is the wizard mode. Here you have the option of giving the number of below grade floors. So you can make that as 1, and oops, sorry, that's 1. Okay, return to navigator, and if I click on finish, you will see that the basement is created, and the color will be different, altogether different. Oops, yeah. So you see, this is the color of basement wall, and what happens is that it creates an altogether different construction. So even though this is EL1 E-wall construction, if I double click this, what you will see is that in the layers, you will have all these, the E-wall construction material 2 is basically taking into account the surface resistance of the wall with the basement, with the ground. So that is being taken into consideration. Okay. So in fact, UW layers, UW wall construction, as you can see. Okay, this is the north wall and east wall. The EW constructions, EL1 UW constructions, EL1 UW constructions is this one. Okay, so this is taking into consideration. So again, as I said, if it is not a cold climate, you don't have to worry so much. You can just straight away model it in. No, that's no problem at all. Okay, so intermediate floor construction. So could you slightly explain more what you want to understand in intermediate floor construction, Mr. Chetan?
So in case of theaters, there will be a balcony inside.
Sorry?
In case of theaters, movie theaters, cinema halls, there will be a balcony inside. So that area will be open.
Right. Okay. So
in case of
for
atrium project.
okay, so let's say these two are your rooms and this is the balcony. Is that correct? Let's assume. Is that what you want to understand?
That can be.
Yeah. Similar
Can.
problem.
Similar.
Similar, right? So these two are the rooms, and then you have this balcony. So this balcony will not, if it is not covered, it's just a balcony, you know, open to air. There's nothing over here. Then this should be modeled as a shade and not as a room. Okay, so this is your shade, which you can model it separately. To model this shade, this kind of shade, let's in fact look if we can actually model it using a building shade. You can actually make a polygon. So here you have the option, create another building shade, and shape definition, you give polygon. So before you do that, make sure to create that polygon. Create polygon. I'll call this as building shade. Sorry, balcony polygon. Balcony shade polygon. Right. So let's say XY00. What are the coordinates? Let's see. Okay. You can get the coordinates from here. So you see. Now let me just copy this shape from here to 0, 0, so that it's clear for me. So the first one, you see XY 0, 0, 0. Okay, this is the first point, and the second point is 403, 218. So this is in inches, I would say. So I'll divide this by 12. 33 and 218 divided by 12. So 33, 18. Okay, so 33 to the right, 18 to the top. 33 to the right, 18 to the top. Yeah. Then again, let's go back here. Let's see this one. 569 and 692. Okay. 569 divided by 12 and 692 divided by 12. So 47 and 57. Okay. So 47 to the right, 57 to the top. 47, 57. Okay. And then I have to enter the other coordinates also. Let's go here. So this is 1141 is the Y. Let's say 1141 divided by 12, 95. So 95 is the Y, and X will be 33. And the fifth point is this one. So Y is 1373. 114. So x will be 0, y will be 114. Oops. 0, 0, 114. Yeah. So those are my 5 vertices. Let's see if we can create a polygon using this or shade using this. Create building shade. This I'll call it balcony shade. Create from scratch. Use polygon. Polygon name is the balcony shade polygon. Done. Let's keep it somewhere x 0, set 48, tilt, let's give it 0, 60. Okay, as you can see, this is the balcony shade that has been created. If I want to move this here somewhere, let's say to this place, y0. Okay, maybe I'll change this to okay, and x, let's say 48.1. Oops, sorry. Okay, so that's how you will model your balcony. Now these are all detailed modeling. See, these all take time. You have to understand whether it is feasible modeling such a detailed one, or you can just straight away take the area of this and model a square one. Okay, really not much of an impact, I would say. Okay, if I make this as let's say, what is it, 48. 48 plus 10, 58. Yeah. There you go. Okay. You see? So I hope how you can model these shapes. You have to have a very good control over your geometry, the points. You need to understand it very carefully and then model these things in. Right. Let's look at some of the previous questions. What if one space is double heighted? You can have one space as double heighted. That's no problem at all. Let's say this space is double heighted. Let's say all you have to do is just increase this height, floor to ceiling height of 18 feet, floor to ceiling height, and that's it. You don't have to do anything else. It may look irregularly shaped, but as far as technically we are concerned, it is perfect because the space is doubled, the volume is doubled. All we are concerned about the volume. We are not concerned about the looks, other than the client, you know, who in most cases is not that technically sound. But ultimately, you are sending this model to EMC, so you should be least bothered about these technical things. If you are technically correct, that's what it matters. Forget about the looks. Right. One more was mezzanine floor. I'm not sure what you mean by mezzanine floor, but you can always create different floors in the initial, you know, go to building creation wizard and all the different types of spaces. You can just create another floor for mezzanine floor and then model it however you want. Just mezzanine floor will be just another floor. Courtyard in the middle of buildings. Okay, that's a tough one. In fact, it's not that tough. So let's say we have let's say this one. Okay, I'm going to save this. And let's say okay. Not sure if we can. Oops. Oops. Okay, so this is the middle one is the courtyard. Let me just see if we can reduce this. Yeah, right. So Mr. Izwan asked how to create courtyard in the middle of buildings. Let's say this is your courtyard. How will you model this? So in that case, what you have to do is break down the entire portion into two parts. Okay, break the entire building into two parts. There are two ways of doing it. One is, creating this one single shell like this. The other is, create two shells. Okay, two building shells. So I'm going to show this Untitled 2, let's say. Let's go and custom. Okay. So my first one will be like this, or even I can put it like this. Okay, that's my first block. Custom blank slate. Okay. There you go. Oh, sorry. This is the courtyard. Okay, done. Next, I'm going to return to navigator, create a new shell, copy the data from here, and what I'm going to do is, before that, previous Okay, it's fine. 0, 0, 0. And I'm going to delete all of these and create new one just for this. Done. It's number 1, the zone. Number 2, done. Yes. You do that and just make sure this again go back once and make sure this is exactly at 0, 0. Next screen. If I click on navigator and if I click on finish, there you have. Okay, that's your neat courtyard in between. So Mr. Rizwan, does that make it clear? This is how you can draw courtyards. And if you look at the walls, it will create an internal wall for this. Okay, so this is automatically created. If it finds two buildings are two blocks are adjacent to each other, it will automatically create a internal wall. It's not an external wall. Okay. Mr. Basil asked, is it possible to import 3D file directly into Equest from Revit or something? I think Revit has an option of exporting it in the form of Equest. But I think you will have to still do some kind of fixes when you import it inside. All right. But yeah, definitely, I think from Revit, there is an option to export the Equest file. Okay, the next question was, can we create opening for skylight? Opening for skylight, as I said, go to the EL roof and create child component, create child window. Oh yeah, I think I was talking about it, right? And I was muted when we were doing it over here, right? So this is the skylight, mostly in malls where you get these kind of skylights. All you have to do is in the roof, just right click and create child component, create child window, and if I say create from scratch, class type, take it from library, and take the skylights. And here you see you have these translucent dome and different types of skylights. Click on OK, and you can enter the height, width, and click on done, and should show. As you can see over here, it is showing up. You can just change. I'll delete this one. But let's say if you want to for the entire thing, I'll select this. I'll see what kind of polygon is being used. So EL2 space polygon 5 is being used. I'll look at the coordinates of EL2 space polygon 5. I can say it is 18.2 and 84.45. I'll go back here. Width, I'll put it as 18.2 and 84.45. So there you go. That's my skylight. Mr. Azim, does that make it clear how you can put skylights? Okay. So great. Yeah, I hope most of your doubts would be solved here. especially with respect to geometry. Okay, I think I have answered almost all questions. Yeah. All right. So great. I think that was a great interaction. Absolutely great. So next, let's look at. So I think everything related to geometry is clarified now. Materials is straightforward. Just make sure that whatever you are putting in is applied in the geometry. Okay, in the geometry, you can always check. It is applied to the geometry. If the roof is GI sheet, then it's an opaque. You don't need to model it as skylight. Just model in, let's say, this roof, or let's say this roof specifically is GI sheet. Let's assume this roof is GI sheet. So in that case, what I'll do is I'll create another construction, roof construction. I'll call this as, let's say, GI sheet construction. And I'll go to this GI sheet. Start. Yeah. Create a new layer, construction layer, GI sheet layer. So material 1, I'll go to library. This is metal, so I'll choose metal. Metal should be somewhere. Steel siding. And okay, let's go with steel siding. Yeah, that's fine. I mean, metal, steel, everything, the conductivity is very high, so you don't have to worry too much. Just either one of it. Can't find metal over here, but you can actually look into it. So steel siding for me, it will do. And that's it. Click on done. So that's your GI sheet. This is the roof with GI sheet. So there's absolutely no use of fixed shade. You shouldn't be worrying about fixed shade. Always go for building shade. It's the best. There's no use of fixed shade. Use building shade. Here's the difference I'll tell you. So let's say now all I'm going to do is rotate this building by changing the azimuth. See, this changes. If I had fixed shade, this will not change. So that's why always go for building shade. All right. So that's with respect to building shell. Internal loads should be pretty straightforward. Occupancy, put in the number of people that has been designed by the architect. If you don't, take the default, that's perfectly fine. Lighting, for the proposed case, you have to take from the design documents. You can either put in watt per area or kilowatt in the proposed case. Don't put both of the things. If you put both of the things, what will happen is it will add up. Same goes to equipment. Okay, and this is daylighting. Okay, and yeah, next most important is air side and water side. So please keep this in mind. In proposed case, if you have VRF, there will be no water side system model. In fact, domestic hot water is not even provided. Maybe in some cases, maybe let's say some hospitals they might provide, or hotels might provide hot water. So in that case, you might want to model. But other than that, hot water is generally not provided. I'm talking about specific related to cooling or heating. So specifically cooling and heating, you should always make sure that if it is a VRF system, all chillers, boilers are deleted from here. Otherwise, your simulation will not run. Right. Okay, so question here from Mr. Philip is, how do we enter the exterior lighting? So for exterior lighting is a direct load on the meter. So all you have to do is create an external lighting schedule. Okay, let me create one here. It will be fraction. Midnight is 1, and from morning 6 it will be 0. Again from evening 6 it will be 1. So that's that. Create one for week. Fraction. Monday schedule and current schedule done. Create the annual schedule. Fraction. Month is 12, days 31. Share lighting week. So after you have created, go to the electric meter. Under direct loads, enter the load whichever you have. Okay, sorry, exterior direct loads. So let's say 31 kilowatt or 30 kilowatt. Click on OK, and exterior schedule, give the schedule, and that's it. That's your exterior lighting. And when you simulate it, let's just simulate it for a minute. Too bad. Okay, let's see what are those. Oops, that's nothing. So let's open this once again and let's see what are those errors. Cannot simulate. Okay, yeah. So GI sheet, it will not be able to simulate because the layer is too thin. So you might have to increase the density. GI sheet layers. Then material, steel siding. I can increase the density to about 2000. I think. Save it. I think now this error should not come. No, it still says the wall is too thin or too light. Density into specific sheet is too small. So maybe increase the thickness of this layer. 0.1. Doesn't matter because really metal it will always, oops, conduct heat. It still shows this error. So let's see if we can add another. Oops, it's stuck. Not sure why. Yeah, there you go. Okay. Maybe what we can do is put another layer of oops, I think it project 34. Crashed. So let's try put an air layer and let's see if that helps. Under layers, I'll go for library and I'll go for air film. Should be somewhere air layer. Seating airspace. Okay. Maybe one more seating airspace. Hopefully that should be good enough. Oh, still one error. Let's see what's that. Oof, has a negative net area. Ah, right. Okay. Okay, so what this means is if you saw this roof basically has a negative net area. So a good way would be to just slightly decrease this 18. I think that should do it. Yeah, there you go. And let's open this. And as you can see here in BPU, external lighting is reflected over here, external usage. Another good question, can we reposition window without going into detailed mode? Yes, you can. You have all the tools. For example, if you want to increase the height of this window, let's say, okay, just click on that window, change your X or Y values. Let's say this would have been at 5 feet. So you reposition that and the height is, let's say, 10 feet. You can all do that in detailed mode. Yeah. So that's that. Any other queries? Any other queries? Right. So when it comes to HVAC, the minimum required inputs which you should put in your detailed mode is basically your, make sure you have your cooling capacity put in. Okay. In fact, if I double click over here, in the detailed mode, right click on this restore default. Make sure you have this fan power. This is for the entire indoor. So in VRF, you have outdoor unit and indoor unit. Okay. Now, this design kilowatt per CFM is for all the indoor units combined. Okay, whatever combined power, this is for the fan. This is for supply fan. Okay. So sum up the CFM, sum up the kilowatt, divide kilowatt by CFM, you'll get that kilowatt per CFM. Enter that, and make sure you enter the flow parameters also. Okay. And then under cooling, For the outdoor unit only, you will get the COP. In the outdoor unit specifications, you will get the COP. So inverse of COP is your electric input ratio. So these are the minimum things that you must always enter when you are giving details about VRF unit or anything, even if chilled water unit, and of course, yeah, the cooling capacity, the total cooling capacity. So number one kilowatt per CFM. Number two, the flow parameters design CFM. Number three, the total cooling capacity. Number four is your electric input ratio. Okay, cooling capacity and electric input ratio, these are for the outdoor unit, while in the fans it is for supply unit only. Fan power and flow parameters, these are for indoor units, while the cooling is for outdoor unit, the cooling capacity and unitary power. What is kilowatt in fan power? Now kilowatt in fan power is basically the sum of the indoor supply fan power. So it's given, it's actually the demand load. Kilowatt is, it means demand load. You can actually check it any, let's take up any VRF unit. Any technical data sheet. Let's download a sheet. It's actually called submittal sheet. So submittal data sheet, go there. VRVS. So you can see over here, you have outdoor unit, you have indoor unit separately. So let's take up one VRV outdoor unit. Let's say 72,000 BTU per hour. So here you can see this is your rated cooling capacity, 69,000 BTU per hour, and then energy efficiency ratio. This is in IP units converted into SI units. This 15 is in, I think, IP units. Yeah, IP units, absolutely. Convert it into SI units. So be very careful whether this EER is in SI units or IP units. Okay, so 15 EER to COP, and straight away do a conversion online. That's one. So Mr. Anas asked, other than AC loads, equipment loads like elevators. So elevators do not impact the space loads. Yeah, Equest does take IP units, but when it comes to EIR, be very careful. It is the inverse of COP. The COP is in SI units. So be very careful. This is, as you can see, the unit is BTU by BTU. Okay, so be very careful what you are entering. Convert ER 15, convert. So 4.396 is my COP. So the ER is EIR, sorry, electric input ratio 4.39 inverse. So 0.2277. So this is what I'm going to here enter 0.2277. And the cooling capacity, as it was said, 69,000 BTU per hour. So I'll enter that. So that's the data from outdoor unit. All right. So that is the data I'm capturing from outdoor unit. And then there will be multiple indoor units. Let's see some of the ceiling suspended, non-ducted. So let's say 12,000, 6 of these. There may be maybe 4 of these and 1 of these, let's say, connected to the single outdoor unit. So these are both connected. As you can see, these are both indoor units and these are connected to the single outdoor unit. So let's see over here. Here you can find out the cooling input power in terms of kilowatt. Okay, so that's the input power. So you can create an Excel sheet where you have listed the outdoor unit. So outdoor unit, okay, and then indoor unit. Oops. I want to put in some more just in case. Okay, so here I'll put supply fan power and supply CFM. Okay, and that's it. Outdoor unit. So single outdoor unit can have multiple. So outdoor unit number 1, let us say indoor unit number. So I'll say I1, I2, I3. Call this O1. We'll merge this. Okay, so this is how it will be. Okay, 1 outdoor unit is connected to 3 indoor units. So this cooling capacity and the COP will be the same. So cooling capacity was 69,000. EIR or COP, I would say, was how much? 4.36, I think. You can just put in, oops, one more column, merge this. So your EIR is inverse of this. Okay, and then supply fan power, let's say 0.03. You can also put in the model number over here, number E, and for the other one, okay, this is also 0.03, 0.03, fine, fair enough. So 0.03 supply CFM, you can always find out. It should be given somewhere. Supply flow, Okay, here airflow rate in CFM, it is high. Take the highest one. Okay, so that is 420. Oops, sorry. And in this case, the airflow is 441. So 420, let's say 420 and 441. So sum it up. For entry into Equest, what I'll do is sum all these and then sum all these. Okay, for Equest entry and plus CFM. This is CFM. This is kilowatt. Okay, so kilowatt per CFM will be kilowatt divided by CFM. Oops. Yeah. Make this into okay. So that's 0.000, 4 times 0 and 7. So I'll go to fans. I'll put it here 0.0007, and then under flow parameters, I'll enter whatever the flow rate, total flow was 1281. So design CFM 1281. So that's what you have to enter for VRF, because you encounter VRF units most of these days. Okay. So another question was, are context buildings to be modeled as fixed shade for baseline case rotations? No. Adjacent buildings are not supposed to be modeled in both baseline and proposed case. It is only the building shades which you can model. Another question was, should we input all the details shown in dialog box? No, you don't. The only details which I told you to enter are the ones you have to enter. You don't have to worry about any other inputs when it comes to HVAC system, especially at the system level. We'll see what inputs are required for the in fact, let me just finish that up right now, and then we'll go into the break. For the zone, the only input that you require is the indoor design temperature, the thermostat schedule, and if you want, you can give the airflow. Otherwise, there's no requirement. If you get throttling range, enter the airflow. Otherwise, forget about it. The outdoor air. If you have the total flow, just enter the total outdoor air flow. So those are the only things that you have to enter in zone. All right. So with that, I think we'll break for now for lunch, and I think we'll assemble back at 2:30. And at that point of time, we'll see how we have to see various things. All these inputs are visible. Whatever I spoke are visible in the output reports. We'll see how and where to find them. And then we'll also see some of the common errors and how to rectify them.